Dylan Price, and this is research into renewable energy generation and smart grid technology using machine learning techniques. Earth is in a crisis, and climate change is accelerating. Ever since the Industrial Revolution, the Earth's temperature has been rising significantly faster than the rest of the Common Era. Even more concerning is the fact that since the early 1980s, the temperature has been rising 3 times faster every decade. That's roughly 0.3 degrees Fahrenheit. As a species, if we choose to survive, we must organize our resources to ensure a future where our energy demands are met with little to no greenhouse gas emissions. Aside from major crises like famine, drought, and pandemics, climate change is also increasing the strength in natural disasters like hurricanes, fires, and floods, and causing a significant drain on the economy. If you can believe it, even insurance companies are even starting to deny coverage and no longer provide coverage in certain states where these disasters are more likely to occur. All this evidence of this increasing threat is astounding, yet some continue to deny the implications of this changing world and new normal. But there is hope. There are many people more talented and smarter than myself who are developing technologies that seek to curb this change. Cleaner energy is crucial infrastructure moving forward. Municipalities across the globe are investing in solar, hydroelectric, wind, and other technologies, and where capable smart grids are being implemented to help manage the power demand. If you're unfamiliar with the term smart grids, it's essentially a system where the energy production, demand, and storage is monitored continuously to ensure that blackouts do not occur. These different components are constantly in contact, and this is usually done through the Internet of Things. One common way that you could be connected to the smart grid is via your thermostat. For example, if during the summer your energy provider senses a particularly high demand in the evening as everyone arrives home on a hot day, they will automatically adjust your thermostat to a temperature that will help ease the demand on the grid. Energy storage is relatively new, but quickly gaining a foothold, especially as conversations about recycling old large batteries, for example, EV batteries, proliferate. Some of these batteries can be repurposed as energy storage, so it's reasonable to believe that more storage will become available in the future. And that is the ultimate goal. We know that renewable energy is highly dependent on the weather, so how well do the combinations of various weather conditions and energy generation predict the demand in regions? By understanding this relationship, energy authorities can appropriately advise on, monitor, and mitigate potential energy risks. If Earth is only going to be getting hotter for the foreseeable future, managing the power during peak demand will be paramount to preventing civil crises. On a slightly less nihilistic perspective, imagine a world where significant storage has been put in place and renewable energy doesn't have to go to waste, so they say. If the wind is blowing hard at night, the generators could be turned on to charge battery stations for later use. Knowing when there will be little demand but high generation potential will be a vital component to our future. Unfortunately, there isn't much historical information about energy storage, but there is massive amounts of climate and energy data, and it's all available from several different organizations. Additionally, available data for the US energy consumption is really only available at the monthly grain, meaning that daily grain data has to be aggregated up. But with that said, to put this research together, data was collected from the EIA, which is the Energy Information Administration, which contains various levels of generation and consumption data as seen in the raw data. There also is MediaStat, which has a handy Python library for climate and weather information. And lastly, the NREL, which is the National Renewable Energy Lab, which is actually just located south here of Boulder. And they collect all sorts of solar radiance data from across the globe. All of this data that was collected generated about 1.8 million records over the last few years. But all in all, rolling that up significantly reduced the data size. During the initial investigations, it became clear that there was some clear patterns between the generation, the demand, and various weather conditions. This sort of passes the sniff test because ultimately, right, the weather is seasonal and totally depends on where the tilt of the Earth is pointed in a given time of year. But to ensure that the model understood this cyclical nature, it was important to encode dates with a sine cosine feature so it could be understood that January comes after December and then February and then all the way back again. Maybe some of the more interesting things that came out of this research was during the unsupervised learning. And it's pretty clear that climate data is deeply correlated. When there's a lot of sun, the temperatures are higher. Now, these unsupervised methods highlight the intricacy of climate data while also suggesting a rich hierarchical structure. This could be useful for smart grids because it means there are several situations in which they could be efficient. It's interesting to see that 6 components would be needed in order to explain 75% of the variance in this data that was collected. Additionally, when we look at a hierarchical clustering of this data, it has many branches, which suggests some complexity in the data. As I said, complexity is not necessarily bad, but it just means that it has to be highly curated to ensure that it's meeting the right conditions. Another takeaway was that smart grids need to know when demand surges to ensure a blackout does not occur. And supervised learning methods can perform strongly with climate data, specifically when they were predicting high demand. Since these are monthly generalized insights, there's likely an easier path for the model to correctly predict the demand because everything is rolled up as an average or a sum for that month. But given that it has pretty high F1 scores for both high, medium high demand, and then only slightly worse low and medium low demand, I would say that this sort of data is definitely descriptive in helping us understand how an energy authority might be needing to make the appropriate corrections for when the smart grid is triggered. All in all, we really need to invest in more renewable infrastructure. Renewable energy only makes up a fraction of the general US power generation. And if we want to meet the demands of our growing AI initiatives, we have to invest more. Additionally, to save off the rapid warming of the planet, drastic changes need to occur. And that means rapidly moving away from fossil fuel use. The ML techniques that were researched through this process demonstrate predictability, right? Even though it's a complex system, the seasonality trends certainly help describe some of the largest variants. But then other things like solar radiance, how much sun's hitting the Earth, obviously speak to how much we'll be able to generate, and also how much we'd be able to predict what sort of demand would happen on that day. Of course, moving down to daily views and further more granular looks within a region would certainly help fine-tune these models, but of course that would mean also these models would all then have to be set up for each of those specific regions. This is not totally unfeasible. Energy authorities could have their own models, but it might be helpful to think about how a collective model that's fine-tuned for each region would be maybe more efficient or better. And lastly, looking forward, if we want to meet this AI demand, there's going to be an inevitable rush for more energy generation. And this is already motivating Microsoft, Amazon, and a few other companies to restart nuclear reactors to meet those demands. Just kind of crazy to think about restarting nuclear reactors. Additionally, smart grids and other advancements in renewable energies will continue to develop. You know, there's promise with the changes that, or the developments that have happened even within fusion and different types of nuclear reactors that use less water. All of this is a right side on a relatively scary world we live in. But thank you. Have a good day.